Unit 5 Study Guide, Probability Problems, numbers 14, 15, 26 through 31. So in a bag we've got 12 green marbles, 20 red marbles, 7 blue, and 9 yellow marbles. I'm just going to make a note that my total number of marbles is 48. So odds. Remember, odds are what we're looking for compared to what we're not looking for. I have 20 red marbles. So that means 28 of them are not red. So if I simplify that, divide both by 4, my odds are 5 to 7 that I would get a red marble. What are my simplified odds against getting a red? So I start with the amount of marbles that are not red, which is 28, and compared to the ones that are. So my simplified odds would be just the reverse, 7 to 5. 26. What's the probability that you draw one red marble? So probability is what you're looking for compared to the total. So 20 out of 48, you can reduce that fraction to 5/12 or 0.42, 42%. 27. What's the probability that you draw one blue marble? Well, there are 7 blue compared to 48 total, which in decimal is 0.15 or 15%. Now let's look at number 29. You draw 2 blue marbles separately without replacement. What's the probability that you'll draw a blue one first and then draw a second blue marble? Is this independent or dependent? So these are independent since we are replacing that marble. So our first event does not affect the outcome of the second one. We look at how many blue marbles we have, which are 7 out of 48. And if we're looking for compound probability with something and something else happening, we're multiplying. So now our possibility is 6 blue marbles on the second draw, because we have not replaced it, out of 47. And let me just go back and say that since we did not replace it, these are dependent. Now we'll multiply straight across, which will give us 42 out of 2,256. That'll reduce to 7 over 376, 0.02 or 2%. Not a great chance. Now 29, we draw a yellow marble, replace it, and then draw a green marble. What's the probability that this will happen? Is it independent or dependent? Now this one's independent because we are replacing. So the second does not affect, or the first does not affect the second. So we have 9 yellow marbles out of 48. We put that marble back. We have 12 green marbles and still have a total of 48 since we replaced. We'll multiply straight across and get 108 over 2,304, which will reduce to 3/64, 0.05 or 5%. Now let's look at 30. Find the probability that you'll draw a red marble or a blue marble. Is it mutually exclusive or overlapping? So since we're asking one or the other, we're going to add red and blue. We cannot have a marble that is both red and blue in this case, so these are exclusive. So we have 20 red out of 48 total, and then we're going to add that to our probability for blue, which is 7 out of 48. So we add our numerators, 27 out of 48. We can reduce that to 9/16, which is 0.56 or 56% chance. Finally, number 31. Find the probability that you will draw a green marble or yellow. Is it mutually exclusive or overlapping? So we can't have a marble that's both green and yellow, so those are exclusive events. We've got, let's see, 12 green marbles. We'll add that to our chances for a yellow marble, which is 7. Nope. 9. So we'll add our numerators. So 21 48ths, and that'll reduce to 7/16. So we have a 0.44 or 44% chance of that event happening.